The secret behind travel recommendations. This video is based on research titled Attentive Item 2 VEC Machine Learning Method for Recommending Tourist Destinations in Indonesia. Have you ever wondered how travel platforms suggest exciting new destinations? Not just random picks, but places that many travelers end up loving? In this video, we explore how a smart recommendation system helps match tourists with top-rated spots, using real data from across Indonesia. Recommendation systems are everywhere, like YouTube, Netflix, Spotify, and many more. But they're also starting to shape how we travel. Instead of scrolling endlessly through reviews, these systems offer smart suggestions based on how people like you rated destinations. The research uses real-world data from Kaggle, uploaded by the GetLock team in 2021. It contains 10,000 ratings given by 300 tourists across 5 Indonesian cities: Jakarta, Yogyakarta, Bandung, Semarang, and Surabaya. The tourists using a rating score of 1, very dislike, 2, dislike, 3, moderate, 4, like, and 5, very like, for each place. So, what is AI2V? To process the data, the researchers used a method called Attentive Item 2 VEC, or AI2V. AI2V is a method that studies dynamically changing user patterns with various potential new recommendations. These are the two main equations in the AI2V model. The first part, Attentive Context Target Representation, calculates the context representation of the target item by summing the contributions of each context item that has been given attention weights, then transformed using a certain matrix. The second part, User Representation, forms a user representation based on the initial input of preferences to model user preferences in the recommendation system. In this study, AI2V is applied to the tourism sector to generate destination recommendations. The application of AI2V in the tourism sector is a relatively new approach, considering that previously this method was more widely used in recommendation systems in the entertainment sector, such as movies and music. Think of it as a smart engine that understands what types of places people enjoy. It doesn't just look at individual ratings, but the sequence of ratings a tourist gives. So if someone likes beach spots and water parks, AI2V notices the pattern. It pays attention to which items matter most in a tourist's journey. The result? Smarter and more relevant travel recommendations for many users. Here's how the AI2V system works. Data preparation involves converting raw data into a structure that is more appropriate for analysis using the chosen method. In the data preparation stage for AI2V, only ratings with scores of 4, like, and 5, very like, are considered. Subsequently, tourists who have rated fewer than 3 destinations are filtered out. This step ensures that the prepared data contains sufficient information to effectively capture tourist behavior patterns. Data splitting refers to dividing a dataset into training and testing subsets. In the context of AI2V, this is done by selecting the last visited destination from each user's list as the test data, while the remaining destinations are used as the training data. An attentive context target representation refers to the vector-based representation of both context and target destinations. The target destination is the one for which a recommendation is intended, whereas context destinations are the previously visited locations that appear in the same list as the target destination. A multi-attentive user is an aggregated representation of each tourist, constructed based on the previously identified target destinations. This representation captures user preferences by integrating information from multiple attention mechanisms. AI2V similarity function. Once the attentive context target representation and the multi-attentive user representation have been computed, the subsequent step is to determine the AI2V similarity function. Making recommendations are generated by ranking the values from the AI2V similarity function in descending order. A higher similarity value indicates a stronger relationship. To enrich the information in the resulting table, the destination codes are then matched with their corresponding names and cities. Performance evaluation testing data is utilized to assess how well the AI-2V model performs. The effectiveness of the recommendations can be measured using mean percentage ranking, MPR, which represents the average percentile position. So, which destinations came out on top? Here are the 5 most recommended places by the system. 1. Keraton Surabaya. 2. Sanghyang Gulid. 3. Desa Wisata Gamplong. 4. Jogja Bay Pirates Adventure Waterpark and 5. Jogja Exoterium. These results highlight spots that tourists often rate highly, reflecting general interest and satisfaction. The MPR score was 0.48976, indicating a reasonably strong performance. Why it matters? Because this research shows how data and AI can improve our travel experience. By analyzing tourist behavior, systems like AI-2V can help people discover places they might not have found on their own. It's not just helpful for tourists, but also for cities and travel platforms to promote destinations more effectively. So if you see a recommendation that just makes sense, remember it's not a coincidence. Behind many of the things that feel easy today, there's smart technology doing the hard work. That's all from me. Thank you for your attention.